Okay, here by the given data, Z1 comma Z2 comma Z3 are the vertices of triangle ABC, and here the given data is modulus of Z1 minus 3 is equals to modulus of Z2 minus 3 equal. This is the value they given. Here the complex numbers satisfying the condition Z1 plus Z2 plus Z3 equals to 9. Then find the nature of the triangle ABC. What is the nature of the triangle ABC? Listen ma here. So by data, here the given is modulus of Z1 minus 3 is equal to modulus of Z2 minus 3 is equals to modulus of Z3 minus 3. What is this meaning geometrically? Z1 is Z1 comma Z2 comma Z3 are equidistant from the point 3 comma 0. What is this meaning? 3 comma 0 to Z1 distance, 3 comma 0 to Z2 distance, 3 comma 0 to Z3 distance are equal. So means here that implies 3 comma 0 acts as circumcenter of triangle ABC. This is okay. First point you got it. Next one, centroid you can calculate. Now centroid of triangle ABC equal to, what is the centroid of triangle ABC ma'am? Centroid of the triangle nothing but ma'am Z1 plus Z2 plus Z3 by 3. But till now you are not using this point. So Z1 plus Z2 plus Z3 equal 9 they given. So 9 by 3. What about this value? 3. That is 3 comma 0 is centroid. So automatically centroid you got 3 comma 0. Circumcenter you got it 3 comma 0. Are those entries also 3 comma 0? So what is the nature of the triangle? That is the equilateral triangle. That's it. So if you know the geometrical meaning for the complex notation, whatever the bit is given, you can do easily. I hope that it is understanding. Okay, clear. Next. Now here few points I will explain now geometrically. Argument of Z2 minus Z1, argument of Z1 minus Z2. Is both values are same? If they are different, otherwise if they are different, what is the exact difference between the argument of Z2 minus Z1, argument of Z1 minus Z2? Okay, difference is there compulsory. Now we will cross check what is the exact difference. Okay, listen all of you. For example, let this is Z1 ma, let this is Z2. This is Z2. Maybe in the physics I hope that it is completed for you. If A comma B are the 2 points with the position vectors OA bar and OB bar, then how you can represent the AB bar value? OB bar minus OA bar only na. So OB bar minus OA bar means A is initial point and this indicates a vector starting from A. It is direction from towards from A to B. Same concept in the geometry also, complex numbers also. So here ma argument of Z2 minus Z1. Argument of Z2 minus Z1 means the direction. This indicates the first of all Z2 minus Z1 means this is the value and the direction is towards from Z1 to Z2. This is the initial point. And argument they are asking na. So somewhere here the let this is the real axis, that this is the imaginary axis. You can shift the origin, okay, which is coincide with this value. So if it coincide, automatically maybe I hope that it is like this, let it be like this. Then argument of Z2 minus Z1 means this angle theta. This is the logical meaning. For example, okay, so Z2 minus Z1 means that is a directed line segment, not modulus. Z2 minus Z1 only I am asking. What is Z2 minus Z1 indicates? Z2 minus Z1 means that is nothing but a directed line segment towards Z2 starting with Z1. Now argument means like this we have to take it. Now for the same thing, for example, Z1 is here, let Z2 is here. Okay, if they given like this, argument of Z1 minus Z2. Z1 minus Z2 means here Z2 is the initial point and the directed towards like this. Then they given argument na. So argument means how you can do? You can shift the origin from 0, 0 till here. That means you may get the, by shifting the origin, maybe let it be like this. Then if this is the real axis here this is the argument we have to take it. Let this is the argument. So here argument of Z2 minus Z1, argument of Z1 minus Z2, meaning is like that. Catch that point, simple point. Okay, once again I will explain to you. So here this is the vector concept. Maybe I hope that all of you know this vector concept in the physics concept. AB bar, if A comma B are the 2 points, with A is a point with position vector OA bar, B is one more point with position vector OB bar, then AB bar equal to OB bar minus OA bar. So OB bar minus OA bar means here this is the initial point, A is initial point and B is towards B direction. Same thing here also. If you observe, leave this argument, Z2 minus Z1. This Z2 minus Z1, Z satisfies the condition Z2 minus Z1. Means what is that meaning? Z2 minus Z1 is a directed line segment. Directed line segment. And the direction is nothing but Z1 to Z2. This is the starting. In that case, if they give an argument, simply you can shift the origin from 0, 0 to this point. Then this is the argument. This is the argument. Now here if they observe, this is the logic. Argument of Z1 minus Z2. What is this meaning? Argument of Z1 minus Z2 means argument of Z1 minus Z2 means starting with Z2, directed line segment towards Z1. And when you are calculating argument you can shift the origin from 0, 0 to Z2. Then this is the argument value theta, like that. Okay, just observe that difference. Okay, now so argument of Z2 minus Z1, argument of Z1 minus Z2, difference it is there. Yesterday I given a rotation theorem or Coney method. I given yesterday. In the previous class I given rotation theorem or Coney method. A rotation theorem or Coney method means, for example, here it is Z1 is there. Let Z1 is equals to R into e power I theta. Z1 is equals to R into e power I theta. What is that meaning? Z1 is one complex number with modulus value R and argument value theta. Now here if you observe, let this is the real axis. This is the real axis. If I rotate the same thing with an angle, something, I displace this value like this to get Z2 value by making an angle alpha. Then how I can write this Z2 value? Even here if you observe, this magnitude of Z2, magnitude of Z1 both are same. Modulus value same. So only the difference is this is theta. You rotating one more angle alpha. So how I can write that Z2 value? Z2 is equals to R into e power iota of theta plus alpha, like this only now. So basing on this, how I can get, mom? That implies Z2 equal to R into e power I alpha into e power I theta. Now this R into e power I theta means nothing but Z1. So Z1 into e power I alpha. So this is the relation. Z2 is equal to this one, Z1 into e power I alpha. Now if the same diagram, okay, observe here, same diagram I will give. You have to tell this relation, how this relation will be valid. If this is Z1, of course here one thing is that Z2 means Z2 minus 0. Z1, what is Z1? Z1 minus 0 indirectly. You can imagine like that. Z2 means Z2 minus 0. Z1 means what? Z1 minus 0. You can take it now. Okay, clear? Now, if this is Z2, this is Z3, let this is parallel to real axis line like this. If this is alpha, okay, then how you can derive the same relation? Tell me. Z2 minus 0, this vector equal to this value equal to Z2 minus 0. Instead of Z2 minus 0, what is the value? Here it is Z3 minus Z1. Z minus Z1 equal to, tell me what is the value will be? Z2 minus Z1 into what is the value will be? E power I alpha is the relation. So this is the rotation theorem or Koni method. So automatically here you will get Z3 minus Z1 by Z2 minus Z1 equal to e power I alpha. So if one line this Z2 Z3 relation is given in this manner. The angle between these two lines is alpha. Z3 minus this value is 1. Here they will mention argument of Z3 minus Z1 by Z2 minus Z1. What is argument value? Nothing but alpha. This is alpha, like this. So this is known as rotation theorem or Koni method. When we are doing bits, this concept we can apply. Okay, so Z1 Z2 is one directed line segment. If you rotate through an angle alpha, then the relation between these two values indicated by like this. Okay, ma'am. We can apply this concept, nothing but rotation theorem or Koni method. The basic thing is, from this we can derive. If I replace instead of origin value, instead of this origin value, if I replace Z1, instead of Z1 I can take as Z2, instead of Z2 I can take as Z3. Automatically you will get it. This is the relation. Okay, remember this one. This is the Koni method or rotation theorem. When we are doing few bits, geometrical application bits, there we can use this one. Okay, I hope that it is clear for you. Next, now we will discuss about the exclusively geometrical applications. We will discuss one now. Okay, let me For example, or geometrical meaning. Okay, simply instead of geometrical application means I can use the word geometrical meaning. Geometrical meaning. For example, first one, modulus of, here the given condition is modulus of z minus z1 is equals to modulus of z minus z2. Then we have to find the locus of z. First condition, this one. Okay, geometrical meaning. Here, what is the locus of z? If z satisfies the condition, modulus of z minus z1 is equals to modulus of z minus z2. If they given like this, then what is the locus of z? Simple logic, ma'am. Modulus means, what is the meaning of modulus? Modulus means distance between the 2 points. So here indirectly, if you take z is the point as PA, P. If you take, if z is equals to P, and z1 value one fixed point A, z2 value some other fixed point B, you can take it. Then tell me what that equation indicates. The equation is nothing but PA is equals to PB. If PA is equals to PB, what is the locus of P means? P is nothing but equidistant from the 2 points A comma B. So means if it is A is the fixed point, if this is B is the fixed point, of course here A of Z1 is the point, here B of Z2. Then automatically here Z is the collection of the complex numbers in the organ plane which are equidistant from A comma B, where A is nothing but A of Z1, B is nothing but B of Z2. Automatically what you will get here, maybe one point is here equidistant, one point is here equidistant, one point is here. Like that, if you did it, what is the locus of Z will be? Locus of Z is nothing but the perpendicular bisector. Perpendicular bisector. Bisect means making into two equal parts. Bisect and perpendicular. So perpendicular bisector. So here, what is the locus of Z, ma'am? If they given this equation, then within this case, locus of Z is perpendicular bisector. Perpendicular bisector of line segment joining the points Z1 comma Z2. This is the first point. So whenever, if you are given this condition, modulus of Z minus Z1 is equals to modulus of Z minus Z2. What is that meaning, ma'am? That meaning is nothing but the perpendicular bisector of the line segment Z1 and Z2. Okay, I hope that it is clear. Next, ma'am. One more point. If they given the condition is, next one, this one, modulus of Z minus Z1 plus modulus of Z minus Z2 equals to modulus of Z2 minus Z1 minus Z2. If they given like that, then what that equation indicates? Here also we have to find. Then locus of Z is, then locus of Z. What this locus of Z? If Z will satisfy the condition, modulus of Z minus Z1 plus modulus of Z minus Z2 equal to modulus of Z1 minus Z2. If they given like that, then what is the locus of Z? Simple logic, here also you can take Z as P, Z1 as the point A, Z2 as point B. And then write down. In geometrical form you can write down. If you write geometrical form, what is this meaning? Nothing but PA only, na? PA plus, this is nothing but PB is equal to what is the value will be? AB. This only you will get. Na? So PA plus PB is equals to AB. What is that meaning, ma? Here, if it is A of Z1, somewhere here B of Z2, P is here. PA plus PB equal to AB. Here it is the point P. PA plus PB equal to AB. Where is the locus of Z, ma'am? Locus of Z is nothing but the is any point between the line segment joining AB. So here the locus of Z. Therefore, locus of Z is, what is the locus of Z, ma'am? Locus of Z is any point on line segment AB. So between AB, okay, any point you may take that will satisfy this condition. Modulus of Z minus Z1 plus modulus of Z minus Z2 equals to modulus of Z1 minus Z2. This is the next point. I hope that it is clear. So here the locus is nothing but any point between the points A comma B. The point P lies on the line segment, which is part lies in the A to B is the value. Next, after this one, for example, if the point is modulus of Z minus Z1 minus modulus of Z minus Z2 is equals to modulus of Z1 minus Z2. If they are given like this, modulus of Z minus Z1 minus modulus of Z minus Z2 equal to modulus of Z1 minus Z2. Then what is the locus of Z? Then what is the locus of Z? This is the one. Same here also. Z as P, Z1 as A, Z2 as B. You can take like this. Then according to given data, this is the given condition. Modulus of Z minus Z1 minus modulus of Z minus Z2 equals to modulus of Z1 minus Z2. Then this, with the help of those values, P, A, B, if you write, what you will get, tell me? This is nothing but AP minus, this is nothing but PB equal to, what is this value? AB. What this equation will give? AP minus PB equal to AB. Means, here listen, A, or first 3 points you can take it. Let these are the 3 points. According to given data, AP minus PB equal to AB. How you can write? AP, if you take AP minus PB. No. If this is the point P, AP minus, this is the point P, if you take it, then cross check, one time cross check, AP minus PB equal to AB. Means, what is the locus of P, ma'am? Locus of P is, here if you observe, locus of P, this P point, where I can take? Here you may take valid, 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 like that. From here you may take valid. After B, anywhere you can take, automatically what you will get, ma? AP minus PB equal to AB. Means, what is the locus of P here? Locus of P is, locus of Z is a ray, with initial point, with initial point as B. This is the logic here. So whenever, if the condition is given as like this, AP minus PB equals to AB, basing on this one, you will get this the value. Maybe here you may take P, or here you may take P, or here you may take P, or anywhere you can take P. Automatically AP minus BP automatically equal to AB only. Means here what is the position of P point will be? The position of point P will be any point in this direction which is a initial point B, indicates a ray, BP ray. So this is the complex form. They will give like this: modulus of z minus z1 minus modulus of z minus z2 equals to modulus of z1 minus z2. So basing on this condition here the locus of z is a ray with initial point as B. Initial point as B means B of z2 is the point. That's it. So directly sometimes in competitive point of view, JEE mains point of view, sometimes they will ask find the locus of z which satisfies this condition. They will give the options. Locus of z is the line segment AB. Locus of z is a ray with initial point as B. Or locus of z is a ray with initial point as z1 with initial point as z2. Okay, towards A direction, towards B direction, like that. Okay, na? So basing on the options we can proceed. The meaning of this, geometrical meaning of this one is nothing but this one. I hope that is clear. Next one. Next, one more point here they given as modulus of, if they given like this. Next, one more concept, this one. Listen. Then what is the locus of z? Already this we did number of times. Locus of z minus z naught equals to R. Means here z2 z naught distance is R units. So automatically what this equation indicates, mom? For example, if you take z naught is equals to some x naught y naught, where R is the real number, and z is equals to some x comma y. Automatically here if you simplify, what you will get, mom? X minus x naught whole square plus y minus y naught whole square is equals to R square is the value. So this equation indicates the what this equation indicates? This equation indicates a circle with center at x naught comma y naught is the value, and the radius is equals to R units. That's it. So regarding this we completed 2 or 3 bits. So z minus z naught under modulus is equals to R means this equation indicates a circle with the center at z naught and the radius is equals to R units. Okay. Next. Here the next condition they given as modulus of z minus z1 square if they given like this, modulus of z minus z1 square plus modulus of z minus z2 square equal to modulus of z1 minus z2 whole square. Okay, find our locus of z. Here they mention locus of z. What is the locus of z here? Same thing. Even this also immediately you can convert into geometrical form. What is geometrical form? Let z as P, z1 as A, z2 as point B. If I take like this, the point z as P, z1 as capital A, z2 as capital B. Now replace the value. If I replace here, then what I can get, here it is the value. This is nothing but PA square plus this is nothing but PB square equal to AB square. This only na? PA square plus PB square equals to AB square. Means what is that logic, mom? What is the locus of P? Locus of P is a circle. Angle in the semicircle, you know. For example, mom, if you take a circle like this, Let this is A, this is B, somewhere here P. Automatically, what is the condition here you can get, mom? Here it is 90 degree. Angle in the semicircle is 90 degree. So automatically PA square plus PB square equals to AB square. So what about the locus of P? Here you may take, here also angle in the semicircle. Here you may take, these also like this. So here the locus of Z, locus of Z is a circle, with the center. What is the center, mom? With the center as midpoint of Z1 comma Z2, and a radius also you can get it. What is the radius value? And the radius of the circle is equal to half mod Z1 minus Z2. Z1 minus Z2 means the distance between the points AB by half, means radius of the circle you got, and in this case the locus of Z, that is nothing but this one. Otherwise directly you may simplify by taking Z value as x plus iy, Z1 value as x1 plus iy1, Z2 value as x2 plus iy2. If you simplify, automatically you will get the equation also. Okay, next. Next, mom. Already ellipse we completed. Ellipse. Okay. In the ellipse, SP plus S dash P is equals to 2A. One point is given. SP plus S dash P is equals to 2A. SP plus S dash P is equal to A. This is the when we are doing the ellipse concept, there we given SP plus S dash P is equal to A is the value. Means now in complex numbers, how we can represent the whole equation, how we can represent. Listen, ma'am. Let this is A, this is B, this is B. P of Z you may take. Let this is Z1, B of Z2. Then tell me, instead of S this value, S dash is this value, P is fixed. Then how you can proceed this one? Tell me here in the complex form. Modulus of Z minus Z1 plus modulus of Z minus Z2 is equal to some constant. Here the constant value should be greater than Z1 minus Z2 distance, like this. Got it already? This is the concept here. Okay, and here K value should be greater than modulus of Z1 minus Z2. This is the ellipse representation in the complex form. Of course, ellipse only, but the presentation is in the complex numbers. So, with the help of the complex numbers, the equation, ellipse equation, we can represent like this. Okay, modulus of Z minus Z1 plus modulus of Z minus Z2 is equals to K. Compulsory here the distance K should be greater than Z1 minus Z2. Okay, 2A 2A value, what is 2A value? That is always greater than the value of AB distance, like that. So here the important thing is modulus of Z minus Z1 plus modulus of Z minus Z2 equals to K. Then automatically this locus of Z, what is the locus of Z, mom? Locus of Z is ellipse. Locus of Z is ellipse with foci points. What are the foci points, ma? With the foci points as Z1 comma Z2. So the complex form of the ellipse. So the equation, this is the basic concept. This is the basic concept. SP plus S dash P is equal to 2A. And this proof also we given, ma. Okay, just one time refer that concept ellipse what we given. There only you can understand easily. So SP plus S dash P is equal to A, which indicates the ellipse equation with the foci points S and S dash. Now for this same equation, if we write the complex numbers form, then here instead of P you can take it as Z, instead of S you can take one point A of Z1, instead of S dash you can take B of Z2, then automatically the complex form is modulus of Z minus Z1 plus modulus of Z minus Z2 equal to K, where K value compulsory greater than modulus of Z1 minus Z2, which represents a ellipse equation with the foci points as Z1 comma Z2. And circle, regarding circle before only I given. Okay, what is the complex form of the circle? Regarding that complex form already before only we given. What is the complex form of circle? Z into Z conjugate plus some B into alpha plus B bar into alpha plus B into alpha bar plus A is equal to 0. This is the constant value. B comma alpha are the complex numbers already before we given. This is the complex representation of the circle. General equation of the circle. The general equation of the circle in the complex form already given in the previous lecture. Refer it. And this is the ellipse equation. I hope that it is clear. Next. Next one, hyperbola. Even for hyperbola also we given SP minus S dash P equal to 2A. This is the equation we given. You may cross check one time. Hyperbola equation also. SP minus S dash P equal to 2A. Now in complex numbers, how you can represent the hyperbola equation? So for hyperbola equation, modulus of Z minus Z1 minus Z minus Z2 equal to some constant value K, where K value is less than modulus of Z1 minus Z2. This equation indicates the hyperbola equation. So here for this equation directly, this is nothing but SP minus S dash P is equal to 2A. Similar form is there. This is the distance between the Z1 to Z, Z2 to Z. So Z is P, Z1 as S, Z2 as S dash. So automatically SP minus S dash P is equal to constant. So SP minus S dash P equal to constant. That to here the condition K is less than modulus of Z1 minus Z2 indicates the hyperbola. So here this equation indicates locus of Z is hyperbola. Locus of Z is hyperbola with foci points as, what are the foci points? Z1 comma Z2. This is the hyperbola equation in the complex form. This is the complex form. Okay, so I hope that it is also clear. Simple logic SP plus S dash P equal to a ellipse equation. SP minus S dash P equal to a hyperbola equation. There 2A greater than S dash in ellipse, and in hyperbola 2A is less than S and S dash. Okay, basing on that, these are the equations. Next now, while we are discussing about the geometrical meaning, one more thing is there. For example, A is the point as x1, y1 in two-dimensional geometry. B is the point x2, y2. Some P is the point xy. If they given PA by PB is equal to K, or where K is not equal to 1, some integral value. Other than 1 positive integral value. If they mention like this, PA equal to PB, which is equal to K. If K not equal to 1, other than 1 any value which is greater than 1 if they mention like that, or less than 1 if they mention like this. Positive. Since the distance ratio always you will get non-negative only, sorry, positive only you will get like that, but other than 1. In this case, what this equation represents, for example ma'am, if k equal to 1, if k is equal to 1, geometrically I am asking, not in the complex numbers ma, general discussion we are doing in 2-dimensional geometry. If k equal to 1, what I can get? Pa equal to pb na. Pa equal to pb means, what is this meaning? Nothing but p is a point which is equidistant from a comma b. Automatically, what is the locus of p? Locus of p is nothing but the perpendicular bisector line for the line segment AB. Perpendicular bisector line for the line segment AB when k is equal to 1. So same here also in the complex numbers, how we can mention? For example, modulus of z minus z1 by modulus of z minus z2 is equals to 1. First point, equal to 1. Then what is the locus of z? Then locus of z is perpendicular bisector of z1 comma z2 line segment, z1 z2 joining line segment, when if this value equal to 1. Now geometrically, if k not equal to 1, for example k is equal to 2, you can k is equal to 2, then in that case what it will come on? Pa is equal to 2 times of pb only. Now pa square equal to 4 times of pb square. Now if I replace the values and simplify, if I replace the values, what I can get? Tell me. Here it is x minus x1 whole square plus y minus y1 whole square equal to 4 into, here it is x minus x2 whole square plus y minus y2 whole square. So here 4x square I can get, here x square, here 4x square, here x square. Bring this x square this side, what is the value? 3x square plus, here I can get 4y square I can get. If I bring this value this side, I can get 3y square. Next x term you will get, next y term, next constant is equal to 0. Means if I divide the entire equation with 3, x square plus y square plus 2gx plus 2fy plus c is equal to 0. Means what this equation indicates, mom? This equation indicates the circle equation. Simply circle. Same here also. Here if you observe here, mom, now in complex numbers, the same 2-dimensional concept in the complex numbers, how we can mention? Modulus of z minus z1 by modulus of z minus z2 is equal to some constant k which is not equal to 1, represents or locus of z. What is the locus of z, mom? Locus of z is a circle. Locus of z is a circle. That's it. So these are the points, mom, exclusively very important IIT point of view. Okay, generally 2-dimensional forms, but in the complex plane with the help of the modulus concept we can represent the ellipse equation, hyperbola equation, circle equation, perpendicular bisector line equation, and some other form of this one. And previously general equation of the circle is also given. So these are the geometrical meaning for the complex form of the numbers. Okay, ma'am. Next. For example, when we are doing any complex numbers bit, in some bit they will give, if you observe, mod z is equal to 1. When we are doing a few bits, they will give z is a complex number and mod z is equal to, otherwise z is a unimodular complex number. Sometimes they will mention Z is unimodular. Z is unimodular complex number. If you observe this point, Z is a unimodular complex number. Whenever you observe this word unimodular complex number, immediately unimodular means that is the meaning is mod Z is equals to 1. So whenever mod Z is equal to 1, you can take that complex number as directly e power I theta. Okay, why you have to take like this? If Z is equal to e power I theta, what is e power I theta value? This is Euler form of a complex number. If you simplify, what is e power I theta value? Cos theta plus I sin theta. Cos theta plus I sin theta. If Z is equal to cos theta plus I sin theta, what is mod Z value? Mod Z means root of real part whole square plus imaginary part whole square. What is real part? Cos theta. So here you will get cos square theta plus sin square theta, which is equals to 1. So mod Z is equal to 1. So whenever you are doing, if they will mention Z is a unimodular complex number, immediately in order to solve such a kind of bits competitive point of view, it is easy to take the value as Z is equal to e power I theta. If you take Z is equal to e power I theta, then automatically that bit will be easy for you. So competitive point of view, remember this point also. Okay ma. Next, one more example. Here the given is one example they given. Listen, this is clear, this concept. So here the bit is they given as if 2z1 by 3z2 is purely imaginary number, then find the value of modulus of z1 minus z2 by z1 plus z2. Even basing on this model, 2-3 bits are there in our Narayana material also. If they mention, this is the example they given as if 2z1 by 3z2 is a purely imaginary number. This is a purely imaginary number. Then find the value of, this is the value, modulus of z1 minus z2 by z1 plus z2. How you can calculate this value? Listen here. If you observe here, by data, they given 2z1 by 3z2 is purely imaginary number. They given as purely imaginary number. So pure imaginary means you may take 2z1 by 3z2 equals to some I into k. Purely imaginary number. They given as a purely imaginary number. So purely imaginary number means iota into some value, real number. Purely imaginary means in this complex number there is no real part. Then only you can say purely imaginary. So with this one, what is the value? Z1 by Z2 you will get Z1 by Z2 equal to what is the value? 3ik k by 2. This only you will get now. Since here it is the value 2z1 by 3z2 is a purely imaginary number. So purely imaginary number means 2z1 by 3z2 equals to ik. Purely imaginary. So automatically what you will get ma? z1 by z2 equals to multiply 3 by 2 this side, then 3 by 2 ik. Now while entering into this bit, first we know that modulus of z1 by z2. What is the formula for this one, ma'am? Modulus of z1 by modulus of z2. And for any complex number, modulus value equals to its conjugate modulus value equal. If you take any complex number, ma'am, the complex modulus value, conjugate complex value, modulus both are same. Now remember these 2 points. If you observe, we have to find now, here it is the value we have to find modulus of z1 minus z2 by modulus of z1 plus z2. Now this value, ma'am, in numerator I can common z2, denominator also I can common z2. If I common z2 here, I can get modulus of z1 by z2 minus 1 by modulus of z1 z2 plus 1. Now this whole value I can written as modulus of z1 by z2. How I can mention z1 by z2 value? This is the value. So 3 by 2 ik minus 1 by this value, 3 by 2 ik plus 1, and modulus of z1 by z2 given as modulus of z1 by modulus of z2. So this value separately I can mention like this. Now if you observe, this is one complex number, minus 1 plus 3 by 2 ik plus 1 plus 3 by 2 ik. If you observe modulus values for this complex number and denominator complex number, for the numerator complex number, for the denominator complex number, what you will get modulus value? Both are same only. What is the modulus of this complex number? Tell me. A root of minus 1 whole square plus 3 by 2k whole square is the value. Of course, minus 1 whole square is plus 1 only. Even in the denominator also, if you calculate the value, modulus of this complex number, what you can get, ma'am? 1 square plus 3k by 2 whole square. So what you got in the numerator value, denominator value, both will be same. So both get cancelled, which is equals to 1 is the value. This kind of bits, are very, very important. Exclusively JE mains point of view. So careful regarding this one also. So basing on this, we have to proceed like this. Okay. Thank you.